Welcome to the video lecture series on principles of compiler design. This is Dr.K.N.Sivabalan. In today's video lecture, we'll be learning about introduction to semantic analysis. This is Dr.K.N.Sivabalan. So the purpose of semantic analysis is determining the meaning of declarations, definitions, and expressions. For instance, when you write a program, you are supposed to use a variable. A variable can accommodate a value. When it accommodates a value, then it is called as a definition. But initially, if it don't accommodate a value, you simply declare it a data type, then that is called as a declaration. And when you associate this variables in a form of mathematical expression, then that is called as an expression. So all this are actually determined with a meaning with the help of semantic analysis. It is also semantic analysis also determines the meaning of the tokens. So tokens are actually used to form the expressions or a keyword. Semantic analysis is responsible for type conversion, both implicit and explicit. So implicit conversion is a mechanism which conversion happens automatically, and explicit, we have to specify what type of conversion it has to perform. Manually we have to specify. So that is called as explicit conversion. In implicit conversion, there won't be any data loss, but in explicit conversion, there will be a data loss because we try to accommodate a large data type inside a small data type. So in that case, there will be data loss. And it also determines the dynamic range of data types. Dynamic range in the sense, if you have an integer variable, it will have a minimum value to a maximum value. So this minimum to maximum range has to be determined by semantic analysis. Now, the other roles of semantic analysis, it actually ensures the syntactic constructs in the program which derives the meaning or not. So semantic analysis operates with the help of context-free grammar and semantic rules in order to evaluate the meaning of the expression or a statement. A context-free grammar associated with the semantic rules is called a syntax-directed translation. In short, semantic analysis can only function with the help of context-free grammar and semantic rules. And when we talk about semantic rules are additional information which are given to the productions. Now, how we can give this additional information? When we want to give this additional information to the productions, it is given in the form of attributes. Now, these attributes are broadly classified into two types. One is called as synthesized attribute or S attribute. The other is called as inherited attribute or L attribute. So, this synthesized attribute, if the value of the parent is determined by the value of its children in a production, then it is called as synthesized attribute or S attribute. So I have taken an example here. S equal to E tends to A plus B, where E is called as a parent and A and B are called as children. Now you can see here the value of A and the value of B is added together and it produces the value of B. That means the result is actually stored in E. So it generates the value of E. So that is the reason why this is called as synthesis attribute, because E is called as a parent. E's value is determined by its children called as A and B. Now when we talk about this inherited attribute, it is called as L attribute. The value of children is determined by its parent and its siblings. Instance, we will take up the same example. E tends to A plus B. Now A value is determined by E value, which is called as a parent, and B value is determined by A value, which is also a sibling for A, which is also a sibling for B. Now see here, A and B are siblings because both are lying in the same level. Now B value is actually determined by A value, B value is determined by A value. So this is called as inherited attribute or L attribute. Now these are called as the productions and associated semantic rules with it. So I take up a production E tends to E plus T, and the semantic rule associated with that is E dot val. VAL is called as value, and E dot val plus T dot val will be resulting in the final value called as E dot val. Now E tends to T, so E dot val is equal to T dot val. The value of T value will be stored in E value. Now T tends to T star F. Now in this case, value of T dot VAL multiplied with F dot VAL will be producing T dot VAL. T tends to F. So value of F dot VAL will be stored to T dot VAL, and F tends to NUM. A number is already a terminal. So we cannot use VAL because number is already a value. So we write it as f dot VAL number dot lexival. So whatever the value we are getting here, that will be assigned to f dot val. So number dot lexical value. Lex value is called as a lexical value. Lexical value is a specific attribute to actually fetch the value here. Now we'll go for a tree now. Now we will take up this expression, perform the syntax director translation for the following expression. Now we have to evaluate this expression 3 plus 4 into 5. So you know that the value will be resulting in 23. Now we will just do it from the scratch. Now I abbreviate this productions for this expression. Now we will try to evaluate from the bottom. So f tends to num. So f tends to num is number is having 3. So automatically f dot val, we will take up this production f dot val is equal to number dot lexical value. That means the number value will be assigned to f dot val. Now so f dot val will be 3 here. Now we take up the second tree here. So this tree is getting evaluated. Now number is equal to 4. So now we apply the same production f dot val is equal to num dot lexical val. Now number dot lexical val will be resulting in f dot val is equal to 4. Now we will take up the third production here, third tree here, f tends to num. So again number is equal to 5. Now this number 5 will be stored in f dot val. We will take up the same production, f dot val is equal to 5. Now next we will try to evaluate this tree t tends to f. So t tends to f, we will just look into the what is the semantic rule for this. T tends to val is equal to f dot val. That means the value of f will be stored in value of t. So now we will know that t dot val will be 3 here because f dot val is equal to 3. Now we will go to the next one. So we will go to evaluate this tree. So t tends to f dot val. Again we apply the same semantic rule. T dot val is equal to f dot val. So t dot val, f dot val is equal to 4. So t dot val will also be 4. So t dot val will be 4. Now we will try to evaluate this e tends to t. Okay. Now we will see that protection semantic rule associated with that. It is e dot val is equal to t dot val. Now that means t dot value will be stored in e dot value. So t dot value is already 3. So e dot value will be 3. Now we try to evaluate this tree. This tree will try to evaluate. So now this is associated with the semantic rule called as t dot val is equal to t dot val into f dot val. That means t dot val and f dot val are multiplied together. The result is getting stored in t dot val. So here t dot val is 4 and f dot val is 5. So 4 into 5 will be 20. So t dot val will be 20. Now we will just evaluate the top tree. The top tree is e dot val plus t dot val is equal to e. Now we will just apply this semantic rule. E dot val is equal to e dot val plus t dot val. So result of e dot val plus t dot val will be stored in e dot val. So e dot val is 3, t dot val is 20. So 20 plus 3 is equal to 23. So e dot val is equal to 23. So now this is the way of actually evaluating a semantic tree with the help of the semantic rules which is given over here. So thanks for watching a video. Have a good day.